We're given a graph. We want a reflection over the y-axis. So again, you can take each of your individual points and change those x values. So if it's 3 this way, this point will end up there. This point ends up here. This one goes over to there. And this one, which is 5 away in that direction. Connect the dots. Perfect. And there we have a reflection in the y-axis. It's asking for the domain and range of the original one and the image graph. So the original one, in interval notation, the smallest value for x is -3. The largest value of x is 5. The smallest value for y is -2. The largest value for y is +2. So there's our domain and range of our original one. A reflection over the y-axis. Again, put your y-axis, think of it in your head. Think about things going over there. That's horizontally. That means your x values are the ones that are getting changed. Notice how that affects our domain and our range. Our domain, which was from -3 to 5, is now from -5 to 3. Can you see that both of those values got multiplied by a -1? And your biggest value, when it gets multiplied by -1, is now your smallest value. And our range didn't change. So we had the graph to help us do our domain and range. And typically, that's exactly what you would do. You would draw your graph, then you do your domain and range of your original one by looking at your graph. And then you looked at your graph to do your domain and range of the blue one. That's naturally how most people would do this. You will get some questions on final exams where they sometimes don't give you the graph. They just say, if my domain was 2 to 7, like that, with a round bracket and a square bracket. That means the square bracket means that value is included. The round bracket means that it's not included. They might say, if this is the domain of f of x, what is the domain of these two? So you don't have a graph. You can't take this advantage of being able to just say, here's my one graph, I drew my other graph, I know where it's going to be. So what could you do? Well, if you wanted to, you could make up a graph. It's supposed to go from 2, pick a point anywhere starting at 2, to 7, 3, 4, 5, 6, 7. Maybe that's your new graph. Does that have a domain from 2 to 7? Oh, but my graph included 7. Do you know how to show a graph doesn't include 7? A hollow point, right. So I could have, if I really wanted to graph it nicely and not erase it all, I could have done a hollow point. Or maybe you drew an asymptote and had it swoop up to that asymptote. There are some options there. But if I chose this as my graph, and I did f of -x, that negative, that first one is inside. That's going to affect my x values. It's going to flip it over y. Can you see that the new domain of that one would go from -7 to -2? Okay, but you're not given the graph. So sometimes you can make up something to help you think about it. Or could you just directly go from this to this answer? Could you directly go, if it's still asking me for the domain of this one, that negative is outside the function, it's affecting the y values. It doesn't affect the x values. So this second one, the domain would stay the same, because it's only my y values that are being affected. So a big theme that comes up in this unit is trying to figure out what's getting affected. Is it my x values or my y values? Is it inside my function or outside of my function? And how can I apply that knowledge to a whole bunch of different things? To the graph, to a single point, to domain, and to the range. Questions for practice on this one are 3 and 13.